We're still in section 5.5 here. Let's look at some notation, okay? Let's suppose I have this definite integral from a to b of f of x dx, okay? A, because of where it's at, we call our lower limit of integration. B, because of where it's at, we call our upper limit of integration. And the f of x right here is still called our integrand. All right, now let's look at this, these two statements. If a is in the domain of f, we define the integral from a to a of f of x dx equal to 0. So what are they saying? They're saying automatically, if you're told to integrate where you have the same lower limit of integration as you have upper limit of integration, you can just write in 0, okay? What does this next statement read, basically? It says, suppose that you need to switch your limits of integration, okay? You could do that as long as you put the opposite sign in front of the integral sign. All right, so let's look at our next examples we have here. Our next examples we have. All right, so we have evaluate, and then we have part A, which is the integral from 3 to 3 of x squared minus 8 dx, okay? Automatically, I'm going to say lower limit of integration is the same as my upper limit of integration. So I'm just going to write 0 without doing any work here, okay? Because I noticed that fact. Part B. Part B, we have the integral from 4 to negative 2 of 3 halves x plus 6. All right, this looks a lot like one of the integrals we had at the very beginning of this section. In fact, we had this, the integral from negative 2 to 4 of 3 halves x plus 6 dx, didn't we? Yeah. So what's the difference between what we had earlier and what we have now? My limits of integration are opposite, right? So if I need to change these limits of integration from negative 2 to 4, what do I need to put out here? That negative side. And I'm going to say 3 halves x plus 6 dx. And earlier when we evaluated this integral, we came up with what? 45. But now we have the negative sign, so we're going to say that's negative 45. All right, let's look at what we have next. What we have next is some more properties here, okay? We looked at these properties for integrals where we did not have limits of integration, but they work here for whenever we do have limits of integration. It says this, suppose that I have some functions integratable from a to b, and I have some constant c times f of x. Well, I could do a rewrite. I can pull the c to the outside of the integral and write this as the integral from a to b of f of x dx. And just like we had before when we had no limits of integration, whenever we had f of x plus g of x, two functions added that we were trying to integrate, well, now we're going to look at whenever we have limits of integration. I can still do the same thing though, but I say the integral from a to b now of my first function plus the integral from a to b now of my second function. And then part C, we had before this, f of x minus g of x to integrate those. What did we do before? We took what? The integral of the first one and subtracted the integral of the second one. So we took the integral of f of x and we subtracted the integral of g of x, right? But now the difference is we have limits of integration from a, I'll get my marker right, from a to b. So I need to put those here and here. So that property holds for these definite integrals as well. All right, keep that in the back of your head, okay? So let's look at some more examples here. What do we have? What are more examples? We have if f is integratable, no, it's actually not an example. It's a statement. If f is integratable on a closed interval containing 3 points a, b, and c, then it says this. The integral from a to b of f of x dx is equal to the integral from a to c of f of x dx plus the integral from c to b of f of x dx, okay? All right, let me show you what that means, because a lot of people get confused if they put a c in there. Here's what this basically means, okay? Basically means this. Suppose I want the area under this curve, y is equal to f of x from A to B. I want this area under the curve right there, okay? Now let's suppose that there's some point C in the interval from A to B. I know it's a bad choice, C, because C should be out here, right? Because your alphabet. But anyway, that's what they choose in books. They're going to say C at some point in between A and B. Then it says that the area under the curve between A and B is equal to the area under the curve from A to C plus the area under the curve from C to B, okay? That's what that's saying. The area under the curve from A to C plus the area from C to B is equal to the area of the whole thing. And sometimes this makes it much, much easier to integrate problems. For example, in the next section, the reason why we need to use this in the next section is, suppose we have an absolute value and I want to integrate from A to B right here, okay? Well, this becomes a problem right here. So what I do is I say, okay, that's my C value. So I integrate from A to C plus I integrate from C to B. And it makes my life much easier. We'll see that in the next section though. All right, so let's see what we have next. Next we have some examples. And my first example is going to read this. Find the integral from 1 to 4. Find the integral from 1 to 4. Find the integral from 1 to 4 of 3 times f of x, 3 times f of x minus g of x dx. And then they say if. So in other words, they're giving you some stuff here. If the integral from 1 to 4 is f of x, or of f of x is 2, and the integral from 1 to 4 of g of x is equal to 10. So they're saying if you're given these, find this. So let's see, I'm going to start out with the integral from 1 to 4 of 3 times f of x minus g of x dx, okay? According to those properties we just looked at, I can break this up as the integral of this first part minus the integral of the second part. So let's do so. Let's do a rewrite. The integral from 1 to 4 of 3 times f of x dx minus the integral of g of x dx from 1 to 4. Now, according to what the property part A that we had earlier, it says if you have a constant being multiplied by your function, just factor the constant to the outside of the integral sign, and you have 3 times the integral from 1 to 4 of f of x dx minus the integral from 1 to 4 of g of x dx. All right, let's see what this gives me. This gives me 3 times, what's the integral from 1 to 4 of f of x? They tell me it's 2, right? So I have 3 times 2 minus, what's the integral from 1 to 4 of g of x? They tell me that's 10, right? 3 times 2 is 6, minus 10 will give me a negative 4. The next example. Let's suppose that I have this. Find the integral from from 3 to 6 of f of x dx if, now they're giving us this stuff, the integral from 0 to 3 of f of x dx is equal to negative 2, and the integral from 0 to 6 of f of x is equal to 6, okay? Let's suppose they give us that if part, okay? What do they want us to do? They want us to find the integral from 3 to 6. Now, what do we have? Integral from 0 to 6, integral from 0 to 3, and integral from 3 to 6. It's your choice. You could break this up in different ways. But what I like to do is I like to say the integral from 0 to 6 is going to be equal to the integral from 0 to 3 plus the integral from 3 to 6. Why am I stopping at 3? Because they give me the integral from 0 to 3. All right, so the integral from 0 to 6, let's fill in, of f of x dx. In fact, all of these are f of x dx, right? So in other words, I could break this up like that. What's the integral from 0 to 6 of f of x? They tell me that's 6. Is equal to, what's the integral from 0 to 3 of f of x? They tell me that's negative 2. Plus, what's this integral right here? Well, that's my unknown integral, right? So I just rewrite it as an unknown. The integral from 3 to 6 of f of x dx. Oh, what do I have here? I'm trying to find this part that's unknown and have an equation. I've been doing this since 8th grade, solving equations, right? Instead of x right here, what do you have here? You have an integral sign. But you still solve it the same way. You still add 2 to both sides. So 8 will be equal to the integral from 3 to 6 of f of x dx. And I found what that integral is. It is 8. All right, our last example for this section. Last example for this section says, use a formula from geometry. Use a formula from geometry this time to find the integral from 0 to 4 of x minus 2 dx, okay? So anytime they tell me to use a formula from geometry, what I'm going to do is I'm going to draw a picture that's integrated. I'm going to draw a picture of f of x is equal to x minus 2. All right, draw my axes. Here's the x-axis, here's the y-axis. Remember, axes is plural. All right, so I want to go from 0 to 4. So I want to go from 0 to 4 with my picture at least, right? Well, what does this function do? Where is it at 0? What point is this function at 0? It's at what? Negative 2, right? Where's this function at 4? If you sub in 4, you have 4 minus 2 is what? 2? So you have those 2 points, and you have a line. Ooh, that's a bad line. Let me try to redraw that. Looks like I've been drinking this morning, huh? Well, I promise you I haven't. Let's see. So I need to find what? The area under the curve between what and what? Between 0 and 4. So between here and here, the area between the curve and the x-axis is this. But between here and here, the area between my curve and my x-axis is right here. So what's going to help me to find this integral from 0 to 4? From 0 to 4 of x minus 2 dx. What's going to help me is if I find the area of this triangle and I add the area of this triangle. So let's find out where I'm at right here, okay? What's the x-intercept of this function? X minus 2, where does that equal to 0? When x is 2, right? So that's 2 right there, isn't it? So what am I going to do? To evaluate this, I'm going to find the area of this triangle and add it to the area of that triangle, right? So basically what I'm going to do here is I'm going to take the area of the first triangle, or the area from 0 to 2 of x minus 2 dx, And I'm going to add to it the area from 2 to what? 4 of x minus 2 dx. Now, this is not drawn to scale. This one looks bigger than that triangle, but really, they're really the same size. Let's see whenever we calculate this, okay? How do I find the area of a triangle? 1/2 base times height, right? 1/2 times base times height. So the area of this first triangle is 1/2. The base is 2. And what is the height of this triangle? It's at where? -2. Plus, how about the area under the curve from 2 to 4? That's a triangle as well, right? So I need 1/2 base times height. What's my base length from 2 to 4? It's 2 units long. And what's my height of this triangle? 2. So what happens if I calculate that? That's exactly the same thing, but one of them's positive, one of them's negative. I get what? 0. So what is that? That's really the net signed area from 0 to 4. I have the same amount of negative areas, I have positive area, so it is 0.